Hello, I'm Alyssa, and I'm going to tell you about a different compartmentalized operating system and what QOSS OS might be able to learn from it. So to tell you a little bit about myself and how I got to be here doing this, in about 2017, I discovered QOSS OS, and on the homepage of the QOSS OS website, I quite vividly remember there was this embedded YouTube video. It was called QOSS OS 3.1 Overview/Demo by somebody called Racing Mars. And I watched this video, and I thought, wow, this is how a computer should work. And I was so excited. But whatever hardware I had at the time, I couldn't run QOSS OS on. It was probably a MacBook. So OK, I did some research. What would be the perfect laptop to buy to run QOSS OS on? I bought it. Eventually, it arrived. And I tried to install QOSS OS, and I couldn't. The installer just encountered some error halfway through. I did not get a working QOSS OS out of it at the end. Eventually, I was able to solve this problem by having a friend do the installation for me. I don't know what they did, but they got it to work. And so then I was actually able to use the system, finally, months later. I was so excited. But it didn't work out as well as I had hoped it would. I didn't have an obvious need for multiple security domains because I was just, I was a student. I didn't have to separate clients. I didn't have to separate work and personal, really. But I did want things to be minimally privileged, separated from each other. So what I ended up doing was I started off with quite, just a few cubes, and then I ended up, OK, we can separate this, and eventually I ended up with 1 cube per application. Because really, why should these things be able to interact with each other in a way that I don't know about at all without me explicitly doing that? And that became quite difficult to manage, even with templates and so on. I also struggled with backing up the system. This, I had to do a lot of manual setup to get everything to work the way I wanted, a little bit of tweaking stuff. Getting a Debian template to work, I remember being annoying for some reason. Eventually, I got it all to work. And then, if I could have easily backed up the whole system, that would have been fine. But that was not so easy. And that meant when something went wrong, somehow in one of my template VMs, the RPM database was corrupt or something, there was no way for me to recover from it. And so this was the end of my QOSS OS journey at the time. I came back to it. I've come back to it in the time since. I've used QOSS OS sort of one-off a couple of times, but I wasn't able to use it for the everyday use like I was really hoping. But I was very young, and I was very naive, and I thought maybe we could do this differently. So now, many years later, I'm here telling you about Spectrum. Spectrum is a compartmentalized operating system done quite differently. So some specific, the kind of specific important things about Spectrum, I'm just going to run through quickly. I'll explain these more as in context as they come up later. But Spectrum is upstream first, opinionated, unobtrusive, modern, and most importantly, unfinished. But that's OK, because the world has QOSS OS. I don't know if this is true, but I heard somewhere, I think, that the first version of QOSS OS was put together in 10 days or something, like the first prototype. We've been working on Spectrum now for about 6 years. But taking our time is going to be worth it, we think, and I'll get into why later. And because the world has QOSS OS already, we don't need to rush to fill this need for a compartmentalized system. We can take our time and see how we can rethink it. So for the rest of the presentation, I'm going to focus on specifically differences between QOSS OS and Spectrum, because I think that's where there's going to be the most to learn. But there is also a lot that we do the same. For example, our approach to isolating hardware, very similar. I'm not going to go into that. So the first big difference between Qubes and Spectrum is that Spectrum is an image-based distribution. This is like quite a big movement in Linux distributions overall, away from having a mutable root file system that the administrator sort of directly edits files on and can change however they want. And when you do an update, it's quite complicated because you have to figure out, okay, well, there's this config file and it's changed in the updated package, but the user has edited it. What do we do? Doing these kind of file-by-file changes and updates and whatever, that can be quite, whatever the opposite of robust is. I have lost the word. So this means that everybody is running exactly the same Spectrum image. All the whole root file system is the same. You can't change it. This means that it is very difficult to break things. So installation, the sort of installation failure that I had during when I was trying to install QOSS OS, it wouldn't happen with an image-based system, because with an image-based system, you are just copying partitions into place. There's not really very much that can go wrong. And similarly, updates. You don't have to worry about how do we reconcile that maybe changes have been made here. You don't have to worry about what if some packages end up updated and others don't. You either are running one version of the system or you are running the next version of the system. There is no in-between. And this also provides very, very easy authenticated boot. We know the exact root file system that we are booting into. We can hash it as part of the boot process. We can just make sure that we are booting the exact version of the root file system that we expect. This is a big one. QOSS OS is far more customizable than Spectrum. I really see a big movement in Linux distributions in general away from this sort of focus on absolute customizability that we have seen that you've traditionally been able to do. Image-based systems are one of the motivations for this. It's more likely that you would provide multiple images that people could download rather than letting them sort of completely change out whatever they want on their system. So with Spectrum, what we're really aiming to provide is a reference implementation of compartmentalization where we have made our choices for how the system is going to be set up, what desktop environment you have, that sort of thing. And it is all integrated together into this one nice thing. And if you need it to work in a different way, then Spectrum is probably not the system for you. One fallback that you have in that situation is QOSS OS, which again, really being out there, being very customizable enables us to be more narrowly focused like this. But the other thing that we aim to do is also, we find a lot of enthusiasts want to put together their own sort of lightweight compartmentalization on top of whatever system they already like. We really want to enable that. A lot of this stuff is really badly documented. So in the next little while, my aim is for Spectrum to also become a hub for documentation for, I want to put together my own compartmentalized system that works exactly the way I want for people who want or need that. The user experience of Spectrum is substantially different from QOSS OS and is largely informed by my experiences trying to make QOSS OS work for me. So unlike in QOSS OS where you set up all of your VMs for security domains up front and configure them and so on, in Spectrum, a VM is something that the system puts together for you on the fly. You think in terms of applications. You interact with applications like you would in a normal Linux system. You can install them, you double-click them, they launch. That application is running in a VM, but you didn't need to set that VM up ahead of time. We have a single global file system. This falls out of the VMs not being sort of concepts that you think about are persistent things. So data does not live in a VM. When I ended up with lots and lots of cubes, one per application, there wasn't a lot of the time often a natural place for specific data to live, and I often found myself losing it. It was hard to find where on the system did I leave this thing. In Spectrum, that will be much easier because we have a single global file system from the host's point of view, from the user's point of view. But what applications see by default is nothing. And they can then get access to specific files in this global file system or specific file hierarchies as required. And ideally, that happens at runtime as you need it. So you have an application, maybe a PDF reader. You do file open. That application at that point can't access any files, but it can ask the host to give it a file to open. At that point, you get a file chooser dialog that runs outside of the VM that can see all of your files. You can choose one. The VM has access to that. This uses the XDG Desktop Portal mechanism that was initially developed for Flatpak, and we've had a pretty easy time adapting it to virtualization rather than containerization. We'd also hope to implement other portals in future. There's a camera portal, for example. There's a screen sharing portal. So we should be able to have a much more reactive experience where you can set things up as you need them without additional overhead rather than having to define things in advance. And finally, it's important to us to support multiple instances of an application for those times when you do have distinctly separate security domains. For example, you might have Thunderbird. You might have work emails and personal emails and really want to keep those separate. In that case, the Spectrum way to do things is applications first, domain second. So you would have a personal Thunderbird profile and a work Thunderbird profile. Those have distinct sets of settings. Those have distinct data storage. But when you are initially setting this up, you can start up Thunderbird. You get it in a new VM. You set it up the way you want. You configure all your preferences for how it looks or whatever. And then you can basically save that instance of the application just like you would be used to saving a document. So you can save a copy, call it work, save another copy of your, call it personal, and then from that point on, those two are distinct and can't interfere with each other. Another big difference between Qubes OS and Spectrum is Spectrum is Wayland native. We use the Wayland forwarding technology that came out of Chrome OS. They are able to basically forward Wayland into and out of a VM, including all the shared memory stuff that goes on, without having to serialize it and do slow sort of send stuff over a socket things. This will also later give us access to more features that have been developed for Chrome OS to enable running Android and Linux applications in a VM on Chrome OS, such as GPU virtualization is something that they're working on at the moment. We have chosen, based on our discussions with Wayland developers, to focus on integrating with a single Wayland compositor rather than sort of interposing ourselves in between applications and the compositor to do our stuff there. That stuff would be things like restricting permissions or doing fancy window decorations or doing access control. In Spectrum, this is going to be integrated into the compositor so that there's no additional latency, there's no possibility for a confused deputy. But we don't want to have to write our own compositor, and we don't want to have to fork a compositor to, and then going forward, maintain it ourselves. Spectrum's upstream first focus means that we really want to be maintaining very little code of ourselves, just what's necessary to put everything together into one system. So we are working with the developers of the Cosmic Wayland compositor to basically turn it into a library, expose hooks for doing all the stuff that we need. We can write our custom code that does the things we care about without having to touch any sort of general compositor code that we don't have special requirements for. And later we expect that we'll be able to do reasonably secure acceleration of applications, multiplexed access to a GPU with DRM native contexts that have been developed for Chrome OS. The fundamentals are all in place there. It's really a question of wiring it up. Qubes is based on Zen. In Spectrum, we use KVM. And the big reason for this is that this is where the development momentum is. We've seen a lot of innovation in KVM over the last 5 or 10 years. One real strong example of that is RustVMM. This is a set of libraries for putting together custom virtual machine monitors, the user space part of the hypervisor, that was extracted from Chrome OS's special purpose virtual machine monitor CrossVM, and now this sort of set of building blocks is being used for all sorts of special purpose, limited scope, limited attack surface virtual machine monitors. In Spectrum, we use Cloud Hypervisor, which is one of these. We've contributed to it quite a lot. There's also a lot of work going on to take device implementations out of KVM virtual machine monitors. This means that they can be independently sandboxed. This means that you can come up with you can do a custom device implementation if you need to without having to patch the virtual machine monitor. And so this has also seen a lot of innovation recently. This allows us to do things like, for example, use CrossVM's implementation of a GPU device, but without using the rest of CrossVM, using Cloud Hypervisor. There is some limited Zen support starting to come into RustVMM and also to these other devices and stuff, but it's quite far behind. KVM is really where the focus of a lot of this stuff is, particularly stuff on the desktop that is mostly being done in Chrome OS, but also more broadly. KVM also gives us a much better portability story. KVM tends to support new architectures very soon after basic support for them lands in Linux. And the virtual machine monitors tend to be quite fast too. So unlike in Qubes OS, in Spectrum we have AArch64 support at parity with x86-64. And in fact, I'm doing my development on AArch64 the vast majority of the time. And RISC-V support is also not far behind. It's mostly a question of waiting for all of the packages to build because there is not fast RISC-V hardware at the moment. And there are going to be a few sort of package builds that need to be fixing, but there's nothing fundamental that's stopping us from having support for RISC-V very soon. There are also drawbacks to using KVM. A big one is that we have to have this big host system because we don't have a hypervisor underneath everything like you have in Zen, where DOM0 is just another VM, but a privileged one, or at least another compartment, but a privileged one. In Spectrum, we have the Linux host, and it has to run all of the VMs. And also, because of this architecture, KVM doesn't have a cultural tradition of putting device implementations into their own VMs. They are almost always run directly on your big host. This means that drivers don't tend to be written to distrust the devices, because the host in the traditional KVM architecture has always been absolutely trusted. It's possible that with the move to confidential computing that we're starting to see, where VMs don't trust the host, that we will start to see drivers used with KVM being more robust, but that's yet to be seen. Zen is way ahead here on being designed for distrusting drivers and being able to move drivers into VMs. Spectrum is rolling release. We will not be doing stable numbered version releases like QOSS OS does. The reason we have to do this really is the kernel. When new stable kernel releases come out, they say all users must upgrade. And they do now, to some extent, track security vulnerabilities, but there are so many that it is not feasible for a small project to look through and figure out what are the relevant ones. So we definitely have to provide a rolling release of the kernel. This is way more important to Spectrum than it is for QOSS because Spectrum uses more of the kernel. It doesn't have Zen limiting what kernel stuff is actually required. And we're being more trusting a bit more the kernel to be on top of mediating access to the GPU, that sort of thing. We have more kernel attack surface. We really need to make sure that we are always providing an up-to-date kernel. But this has some really strong advantages to it as well. One is that when people contribute to Spectrum, they are going to be able to see those contributions show up in the normal release that they can use almost immediately. They're not going to have to wait many months for a new version of a stable release. We're also going to be much more better able to support modern hardware. A lot of the time with stable Linux distributions and similar systems, there's nothing fundamentally stopping your new hardware from running it, but a lot of the time it doesn't work anyway because the kernel that is provided by that stable system is just too old. And all that would be necessary to fix it is use a newer kernel, but in many cases that's not possible. So by being a rolling release system, modern hardware will be supported much faster without us having to really do anything. I'm a bit short for time. We're going to be able to find bugs while they can still be fixed. A lot of the time you can, if you find a bug 1 or 2 years later, now somebody is relying on the new behavior and you can't fix it. So, and of course we don't need to spend our time backporting things. Spectrum uses Nix. Nix calls itself a purely functional package manager. I would describe it as a package composition system. That's probably a bit easier to understand. It provides reproducibility of inputs. With a git commit from the Spectrum repository, you know that you know the hash of every build input to that. You can download the whole thing. You can do your build offline. Know that there's no extra stuff sneaking in. This means that you have a complete set of stuff that you need to audit. It means that if we find a regression, we can just go back, build an old version. Everything will build exactly as it did basically at the time, even if it is 3 years ago. We can bisect our way to find where the regression was introduced, what package update did that. This is going to really enable the rolling release because it will let us solve regressions easily as they come up. But it's important to stress there's a system called Nix OS that is built on Nix. Spectrum is not Nix OS. So what's next? We have, to get our initial release out, it has been far too long. So we have a big focus on that. There are some missing features. The GPU stuff, our custom window decorations, we have the path to it, but we don't have them yet. We want to really focus on documentation after that, be this place, the sort of center of the community where people interested in compartmentalization will come and learn about how to put together their own things. Various hardening stuff we want to do. Making the build of the Spectrum image reproducible. Nix provides input reproducibility. It doesn't provide complete reproducibility. You might have multiple threads that race and produce outputs in different order, that sort of thing. The system is currently huge. We have done no reduction of optional dependencies we don't need or whatever. And there's going to be lots more too. So as I end the presentation, I'd just like to acknowledge the funding that has made Spectrum possible. This is both crowdfunding and grants from an LNet Foundation. If I didn't have both of these, it wouldn't have been feasible to spend all the time that I've spent putting it together. And now also to enable other people to also put work into making this something that people can use. So I think we have a lot to learn from each other in our two communities. I want a future in which Qubes OS is successful and Spectrum is successful, and they are complementary. Because I think that the people who are natural Spectrum users and the people who are natural Qubes users, there is some overlap. There is not that much overlap. I think really what I am hoping to do is reach new people who do not currently have access to a compartmentalized system that works for them. So. Questions?
Thanks for the presentation. Yeah, I have some. You said that it's intentionally not very customizable. Mm-hmm. On the presentation before, we had this, one of the problems in Qubes was to set up a proxy to download updates, and it requires patching some scripts. What is your approach with Spectrum in such cases?
So much as we are Spectrum developers try to have a big upstream first focus, we would encourage maybe not exactly end users, but sort of deployers of the system to also have that upstream first approach and come to us and work with us, tell us what they need, and try to provide that as a sort of native feature of the system rather than trying to hack it in.
Okay, so Kerberos authentication in proxy for downloading stuff is coming to.
I have written it down.
Okay. As for the size, you said it's huge. What do you mean it's huge? Is it bigger than Qubes?
I don't know how big Qubes is. Last time I checked, just the host system was about 8 gigabytes, and a complete Spectrum image was 12. That is way bigger than it needs to be.
Yeah.
And it's basically an artifact of Nix packages by default give you everything, and if you don't want everything, you turn it off, rather than some other package repositories which do things the opposite way around.
Yeah, but with Qubes 4.3, I think we just hit 8 gigabytes of the installation. Yeah.
We also need twice as much disk space for updates. So you have an A partition and a B partition. If you're booted on the A partition, you install the update to the B partition and then reboot to the other one. So you need space for 2 versions of the system at once.
And regarding rolling release,
Mm-hmm.
If you are using it for like development or some personal, it's probably okay. But what if there is some regression and you really need your working system, but you also want to like apply security fixes? So that's something we have customers that are concerned with updating at arbitrary time with arbitrary new features coming and maybe breaking changes. So what would you recommend if using in such use cases?
I would say that I don't think that it's feasible to differentiate security fixes and things that will cause you regressions and put those into 2 boxes. I really think that the only way to have a system that is secure is to stay up to date always. And if you have a regression, roll back temporarily, get the regression fixed. I hope we can be very, very responsive for that sort of thing. And because otherwise it's so easy to miss things that do fix security problems but aren't marked as security fixes, or just that backporting them was missed in a distribution, in an upstream project, that sort of thing.
Yeah, in Qubes we have this kernel and kernel latest. Kernel latest is tracking the most recent stable kernel, and kernel default is LTS. So we do provide those timely, kind of timely, and thanks.
It's possible that we could do something for stable releases, but it's really not sort of built for it at the moment. Like, I can imagine how it would work. But my advice to anybody would be, don't do it.
Yeah, especially for the kernel, it should be quite easy because kernel is quite good at stable IBI. So
Yes.
Updating kernel rarely require any user space update, so that you can do them separately. Yeah.
Next question.
Yeah, thanks for the talk. You said it's image-based and everybody runs the same image, but then you update inside a running machine using the NIX packaging system.
No, we use the NIX sort of package composition system to build a new image. So you download a complete new image, ideally at some point with Delta updates, so you only download the change bits, but you get a complete new image. You put that image into your other partition, you reboot into that partition.
Okay, and user data is then located in a third partition?
Exactly.
Okay, thanks.
Yeah, I was wondering specifically, like, how has your experience been with Flatpaks and app images? Because on the Qubes side, it's a mess to install things. I created a page on the user forum of like, this is how the software is provided, and this is how you install it. But it's very hard to like solve the discoverability problem. So I'm wondering if you have insights on how to make applications easier to find with various methods of like installing. Because you have to.
So Flatpaks are not done yet. They're going to be done by the end of the year. But the way that I expect that it will work is that people will be able to use the normal Flatpak store and of their choice, I suppose, and install Flatpaks into the global file system, and then they will be able to, those will be run in VMs, and the system will be very similar to exactly how Flatpaks would work on Fedora, for example. I think that Spectrum has a much easier user story here than it does, than QOSS OS does, because we don't have these. You don't need to install Flatpak, that's supported out the box. You don't need to run your Flatpak store in a VM and figure out then, okay, but now I've installed the Flatpak, how do I get that to run in its own VM? That's all taken care of by the system.
Okay, so Flatpak is basically the main way, and I'm guessing app images is going to be as an extra, like if you really want something, then you can like get an app image, but not necessarily in a store.
Yeah, I did app images first because they were easier. Like running an app image is just way simpler than running a Flatpak. Yeah. But for me, app image is really a sort of easy way to get something going, and Flatpak is going to be the main focus. And then we're going to have to come up with some solution for what do you do if you want to run some proprietary application that gives you a .deb or something. Haven't figured that out yet. Probably won't be too hard to just run it in a Debian container inside our VM image or something like that. Flatpak is the focus.
Okay, and I'm guessing the updates are done through the store. So
yeah.
Yeah, okay, sounds good.